When did you all start? What cohort are you? September 16th. Got it. So I'll post this. Victoria. I need someone to just, or maybe I'll ask them. Okay, perfect. Um, so Victoria's working. Can someone like keep an eye? I mean, I'll try to keep an eye as well, but I'll also have an attention on all of you. It will help if someone can like just look at Victoria, see if they have any questions that come up, any feedback. Um, without further ado, let's start this. You guys are on week 3, day 3, which is going to make things much easier for me because I think yesterday you all got started with some authentication stuff, if I'm not mistaken, right? You didn't do any authentication stuff yet. That's plenty. That's exactly what I'm looking for. So yeah, thank you so much. I'm Johnny, and I am a software engineer at a company called Axiom Labs, and I also teach here part-time. And I also graduated from this boot camp almost 2 years ago, actually. Yeah, and things have changed. You guys are spoiled. You get 12 weeks now. Back in my day, we only had 8 weeks. But you know, it was like for me, it was a big change in my career, like it is for some of you, and it's probably one of the best decisions I've ever taken in my entire life. So today we're going to talk about security, and I probably shouldn't be saying this, but I am not a security expert. But interesting story. I was interviewed by a journalist who thought that I was one. So what happened was a few years ago, my teammates and I, for our final project, we made an app called Oxcord. That was our Lighthouse Labs final project, and it was basically, to sum it up as succinctly as possible, a collaborative jukebox. So imagine you go to a party, you see all the songs that are coming up on someone's Spotify, and you can vote them up or down the queue. And you can suggest new songs, and everyone can see those songs and vote them up or down the queue. So we did that using Spotify's API that would connect to someone's laptop or whatever. And we got that working, and we did really well. People liked it. And after boot camp, I was like, you know what? This is really cool, but I still don't have a job. I need to kind of make myself stand out. So instead of just kind of boosting up my resume with small projects, I put some tutorials together. And one of them was a tutorial for how to connect to Spotify's API, because that's a problem that we had to solve when we were putting together our app, and there were no resources for that to happen. So I just made a walkthrough on YouTube, wrote an article on Medium, and it did a lot better than I expected. And a few months later, I get an email from someone in the UK saying, hey, there have been some security breaches with some Spotify accounts, and so we wanted to speak to some security experts about how their API works. Would you be available for an interview? I'm like, I've been a dev for like 2 months. I didn't say that to him. I thought that. I emailed him saying, I'll check my schedule. And of course I did it. It went well. I mean, the thing is, as long as you know more than the person who's interviewing me, then you're fine. So it worked out well. There wasn't that much to say. I just explained to him what I had already written in the article, which is like, this is how authentication tokens work, and this is how they can be used to access people's information. We will get to that, actually. It's really important to know, especially when we get into authentication, using third-party services to handle that for you makes it much easier. It's probably my recommended way. But I don't want to skip to that now. I think we should start from the very beginning because with your Tiny app, you are going to be using a very simple form of authentication, which is just simple email and password, or username and password. But before we even get to that, let's just talk about, before we even get into passwords, let's just talk about authentication in general. I mean, I think most people in this room are like not that old. We have all like been out recently at some point, and so you know what happens when you go to a bar or a nightclub, and they want to make sure that like only the certain people who can get in, get in. And let's say there's like a guest list, a very, very exclusive, like high-end, I don't know, I've never been to a fancy, what's a fancy club in Vancouver? Like a really rich people one, I haven't been to. Prohibition? Okay, let's go to Prohibition, and only the certain people on a certain list can get into Prohibition. And so you get into, what's your name? Jackie. Jackie goes in, he's on the list, and he goes up, he says, hey, I want to get in here. And then I'm gonna say, well, I don't know who you are. And you're gonna say, oh, I'm Jackie, you're gonna pull out your ID. I'll be, oh, Jackie, yeah, come in, you're good. Of course, we've been waiting for you. But then Jackie, he goes in, he enjoys the fancy drinks, the caviar. I don't know what they have. What do they have in Prohibition? I've never been. What? A liar.
It's just expensive. I don't think it's that exclusive.
Okay, fair enough. So in Prohibition, he has some Prohibition snacks. And afterwards, he's like, you know what? I need to step out. I need to like go grab a taco or something. I'm tired of all this fancy food. I'm just gonna grab a taco, and I'm gonna come back in here. He steps out, and then after Jackie steps out, he needs to come back in. They say, there's been several people who have come in already. So I'm the bouncer. I'm like, who are you? And he says, I'm Jackie. And then we do the whole process again of me checking the list, checking his ID. There's something wrong with this picture here. What is that? Someone stepping out, coming back in, and having to let me know all over again who they are. How do nightclubs and bars and just events in general kind of avoid that? Stamps. Exactly. So you get your Prohibition stamp on your arm. And that stamp makes it so that when you come back in after getting your taco, I no longer have to ask you who you are and check your ID and check the list because you have that Prohibition stamp. Now, bringing this back to what we're here for, what does that look like in terms of web apps? So if you were to go onto prohibition.com in order to see your account and talk to all your Prohibition friends, you'd have to log in, and then you close your tab. But you open another tab again, and you go to Prohibition. I don't want to have to log in again. I don't want you to have to log in again. What do I do as a web app? What does a web app do in order to prevent you having to log in again every time you want to see a different page? Because if you think about it, web apps, web requests over HTTP are, they do not keep states. They are stateless. What does that mean? It means that every request you make for every single page keeps no information about who you are. You ask for something, the server gives it back to you. You ask for something else, there is nothing that the server has, for now, based on what we know so far, about what requests you made beforehand. So it can't check to see who you are. But we do have ways around that. We all know that. What is the way that web apps do in order to prevent you from having to log in again? What's your name? Anthony. So I don't know who to give this cookie to. I'll just give it to you. So when Anthony goes to prohibition.com, what I do is I leave a cookie on his client so that whenever he makes a request after that, that cookie is then attached to the request, and I can see, oh, that's Anthony asking for to see whatever page. And I don't have to ask him to log in again. You can keep it if you want. Or split it with Jackie. I don't know if you're generous, up to you. But that's what servers do. What they do is they leave a cookie on your browser so that every request that you make after having logged in can be verified with some information about you. Now, does anyone know what that information might be? It can be anything. what is the most simple thing? Actually, maybe that's not something that we might know until we work with databases. But let's just kind of throw some ideas out there. What's something super simple that we could keep in order to identify someone as a cookie? Shopping cart contents. Could be a cookie. Really anything that is tied to your user's information in a database. And the simplest one, as you'll learn once you start working with databases, is the ID. You could also use username, but that's probably not as secure because the username can change. You can change your username. But when you get into databases, you'll realize that as far as many things can change within the database, as far as things corresponding to a user, the ID will always, always be unique. So what you'll do, I think, well, you'll learn when you start working on this, is that you'll store the user ID as a cookie on the user. So if I go to any website, let me go to, I don't know, a website that requires authentication. I'll go to GitHub. And you can do this too on literally any website that requires you to log in. If I sign out, who here has not yet used the dev tools? Okay, that's perfect. That's what I want to hear. So with the dev tools, you can look at all different kinds of information. I think so far you've all used it for inspecting elements and also looking at the JavaScript console. What you can also do is look at information that is stored by the web app on your client. And you can do that on the application tab. So I'm going to clear storage to make sure I got rid of everything. And then once I log in to GitHub, please don't be 2FA. Please don't be 2FA. God damn it, it's 2FA. OK, I have to find a code on my text. 1 second. 362621. 2FA is actually a good idea. I'm complaining, but like, it's a really, really secure thing to have, so I recommend it. 362621. OK, so now I'm in here. And I can see all my GitHub stuff. And I can also look on the application tab. And on the left here, I see cookies. And the cookies from GitHub are all of these. Logged in, yes, user session, device ID. And if I get rid of all of these, it doesn't let me get rid of more than one. What if I just clear all of them? There we go. And I refresh. I no longer can access GitHub. Because now the request that I'm making to github.com no longer has those cookies attached. I've only kind of shown you half the picture now, because right now I've shown you what the cookies look like once they're stored on my device, but I haven't shown you what they look like once they're actually going out to the server. Because that's what GitHub actually uses to make sure that I am who I am. So let me just do this one more time. FF2651. And does anyone know where I can go on the DevTools to look at the details of the request that my client, that is Chrome, the request that it's making to github.com? Where can I go inside the DevTools? Sorry? Yes, the Network tab. And here in the Network tab, I can look at all the requests. And I'm just going to look at the main one for the page. Let's go. The next one. If I hit refresh, which is the one that I'm looking for, there we go, this is the one. So this is the request that I made to github.com. This is the response that I got, the response headers. And these are the cookies that were attached to the request that I made. And there are also cookies that were attached to the response. And these cookies are then stored on my browser, and on every subsequent request that I make to GitHub, these cookies are then attached. So basically, I ask for this. Yeah. Hey, would it be possible to share your screen? We just have the oh, I'm so sorry. Yeah, of course. How do I share my screen? Let me see. There we go. Thank you, Lord. Yeah, so I'll make sure I switch to sharing my screen whenever I'm showing code. So what I'm doing is going through the dev tools and on the network tab, looking at all the cookies that are being attached to the requests that I make to GitHub after being stored on my browser. So I'm going to flip back actually the view to the full camera so I can kind of show you what's going on the board. What happens is I have my client, and I have github.com. And then I make a request to GitHub, and then that request is with my login information. So this is going to be like the post request to login or something like that. And then the response is going to have some cookies attached to it. Now that cookie is stored on my browser, and any other request that I make to GitHub is going to have those cookies attached to it, so that GitHub can know that I am who I am, and it can give me access to the information that I'm asking for. Pardon me? They can't see the board? What does it look like on? Oh yeah, I should probably use a darker marker. Let me find a darker one. I don't know if that's like a little bit better. Maybe. Bit better, thank you. I'll try to find Okay. Any questions so far about this whole process of storing cookies and then using them for requests afterwards? Nope. Then let's take a look at what this looks like in code before we move on to talking about passwords. So I have a really simple app over here. I'm going to flip back to my screen. And I have a really, really simple web app. This web app, which I'll share with you at the end of this class, all it does is allow me to, do I have an incognito tab? Yeah, perfect. Localhost 8000. It's a web app that allows me to log in, and once I've logged in, I see a treasure chest, and that's literally, yep.
For this kind of aside, Google Incognito, is it actually incognito or are they just lying?
Oh man, that's questions beyond me.
Because I feel like there's no way to actually be incognito.
I think that it's incognito in the sense that like no one else who uses your computer can figure out what you did. But in terms of Google not knowing what you did, I doubt it. Yeah. So that's the way incognito. So if you have like a shared computer and you want to, or you're using your friend's computer and you want to make sure that they don't know where you've been, I'm not going to ask why, but incognito is usually the best way to do that. So yeah, it's anonymous from other people using on your computer. It's not anonymous from Google. It's probably not. Yeah, I would imagine that they always want to know what you're up to. They probably have like analytics on like what people use incognito for, and I'm sure there are no surprises. Yeah. They all use it for demo sites for their Lighthouse Lab students, clearly. I don't know what you all were thinking, but so I'm going to sign up and make an account. And I'm going to use a password. Password, never do that. But I'll do it. Yeah, of course. There we go. I'm in. And this is great, but this is like literally just showing you what I've already been talking about. Because now if I go to just here, I don't need to go to log in. It'll figure out based on the cookie that I have in here. If I go to application and go to cookies, current user, this cookie now allows the app to know who I am. And I can prove that by deleting the cookie and then trying to access the same link. And now it tells me, I don't know who you are. Make sure you log in. But we're all programmers here, so let's look at what the actual code does. And there's this really cool thing with Node that you can do. You can add a flag called inspect. So this is the app that I'm working with here. Let me open it up, and then you guys can tell me if you can see it well or if I should zoom in a bit more. I'm going to go to server.js, and oh no, this is the one I'm looking for. Server.js. Can everyone see it? Raise your hand if you think I should zoom in some more, or if you're okay. Or, sorry, if you think I should zoom in more, raise your hand. If you're okay, don't raise your hand. Zoom in? Okay. There we go. This is what the app does. It has a login route. It has a check user function, which is, have we talked about middlewares yet? Yeah, okay, yeah, so the middleware is going to be run no matter what route you're trying to hit. And so we have this check user middleware that's running on every route, and if it finds a cookie, then it says, okay, you're logged in, and then it likes to keep going. Otherwise, if it doesn't find a cookie, then it redirects you to the login page. So let's see what that looks like. With Node, I can run -- inspect. So I'm going to kill my app for a second, and I'm going to run, instead of running node server.js, I'm going to run node -- inspect server.js. And what that allows me to do is, if I now go to my app and I open the DevTools, I'm going to see this little green icon over here. And this green icon allows me to open up the DevTools, not for my client-side code, but for my server-side code. And I can even see express listening on port 8000, which is being logged from this server.js. Now, the cool part about that is that now I can set breakpoints on my server code and see exactly what's happening when certain routes are being hit. So I'm going to go to sources and or server.js. Server.js. And I'm going to put a breakpoint at check user. So I'm going to put one right here. And if I hit refresh, now my code is paused. We've done some debugging before, right? We know how debuggers work with pausing at breakpoints and moving to the next line. No? Has anyone never done something like this before? Yeah, that's one way to do it too, to be honest. At work, that's what I'll do sometimes as well. One way to debug is to put console log statements everywhere and just see what's being printed out. Some of my colleagues who have been dev for like a decade still do that. It's convenient. Another way is to use a debugger. And the debugger allows you to kind of pause the code at a certain point and check what all the values are when your code is paused, so to speak. So right now, it's running this check user middleware, but I made it stop right there. And at this point, this is the value of the rec parameter. This is the value of res. This is the value of next. And so rec, what does rec represent? Request, exactly. So the request body has nothing because it's a GET request. and it has the headers, and it has no cookies, which is to be expected because I cleared the cookies beforehand. So now let's see what our code does with the fact that the cookies object is empty. So, yeah. So it's going to set a value to the current user variable. It's going to declare it and assign it to rec.signCookies.currentUser. We can see rec, we can see signCookies is an object that's empty, which means .currentUser is going to be what? If I have an object that's an empty object, and I call empty object dot, I don't know, age, what am I going to get? Undefined. So current user is going to be undefined, which means current user, the variable, is going to be undefined. And do you understand falsiness and truthiness? Perfect, so I don't have to explain that. This is a falsy value, which means all of this code is going to be skipped over, and instead we're going to go to the block of code after the else statement, which just says redirect to login. So I'm going to let the code run by pressing play, and now I'm at the login page. Now let's see what happens after I've logged in. I'm going to disable this because I haven't logged in yet. Play it. Oh, did I not create an account? I think I did. Let me see. Oh, you know how I can check that? I can check what my users are. So I'm going to go. No, I cleared the cookie, so it wouldn't make sense. Okay, I'll go. I'll put a breakpoint at the login route. Here we go. And Johnny and password. I don't need this, don't need this for now. Actually, instead of deleting or removing breakpoints, you can kind of disable them and enable them so that they're still there, but they're just not necessarily in use for the time being. So I'm going to disable these, but not delete them yet. And so now I'm over here. And I can see what's happening as it's looking for the user. It's going to call find user with the username. And find user, what that does is it looks through all of your users. So let's see where that's defined. Data.users.find. Oh, I should have put a breakpoint in here, actually. Anyone know how the find method works? These are our users right now. Data.users, it's an empty array, which is probably, it makes sense because I deleted the server, so all the users are gone. But maybe I could take a bit of an aside to explain how find works. But first, let me just get through this. I'm going to create an account. Disable these. Sign up. Is that a question? Sorry? It's okay. This is going to take me a second. Go ahead. Yeah. Yeah. You don't know. You're defining it. Oh, actually, we'll look into it. We'll put a breakpoint there. Let me just create an account first. So sign up, Johnny, and we'll just make the password Johnny. Perfect. Okay. Did you mean in the middleware? Check user. In here, right? Okay, so let's pause here and we can walk through it together. Johnny and Johnny. Here we go. So we got the request, we got the current user, and which part are you confused about?
When you do request dot current user.
Yeah.
Line 57.
57. Rec current user equals current user.
Well, I don't know what rec dot current user is or what it is that like a built-in thing?
Yeah, so now you're adding value to the request, and then it's going to call next. So now that request will have that current user attached to it. So you're defining it arbitrarily. Yeah, it doesn't have to be current. You could have called it rec.x or whatever. As long as whatever route or middleware is going to be evaluating it is going to look for that same exact key. Yeah, but there's no rule saying that it has to be current user. We're just saying that's to make it easily readable. That's all. Yeah, good question though. Let's look at this login method just one more time before we get into password, because I think that's going to be important, especially once we get into finding passwords. Once I log in, so after having logged out, play this out. Johnny. This find user is going to find the users based on the username that you just passed in. And it does that by calling .find, which is a method built into the array prototype. As of right now, based on what we know so far about JavaScript and arrays and how they work, if you want to find something in an array, what would you do? Let's say you have an array of animal names. So I'm just go back to the console. Actually, I can use this one, might as well. So const animals equals dog, God, cat, and then snake. If I didn't know the order of these, so if I got an array of a bunch of animals that I didn't know the order of, but I knew that somewhere in there, there's a cat, how would I get out that value? Or how would I figure out where it is inside the, yeah, how would I pull out that value? Filter, you could use filter. You could loop over it. So it's easy, or you could use, if you wanted to find out where it is, you could use index of as well. But if you want to find something that's more than just a primitive value, you want to find an object, what do you do in that case? You could loop over it as, in that case as well. But what could you do? Let's say I have users now. This is a little more, because right now, if I want to know which of these, which index the cat is, I would do animals dot index of, and then cat. If I wanted to remove it, oh, const animals. Do I not spell properly? Animals is not defined. Const animals. Oh, it's because I'm still working within where the breakpoint is. Let me just do it here. Sources. I'm just going to play this out. Animals dot index of, and then cat. And now that I know that it's at the one index, I could use that information to like remove it. I can splice it out. I can do whatever I want. If I want to know if animals has a cat, I would do animals dot includes cat, and it would say true. If I put, I don't know, fish, I would get false. Nothing confusing so far. It gets a little bit trickier when we talk about objects. Because now, if I say const users equals, and then I have an array of users. So one with the name of Johnny, and one with the name Tom. If I put users dot index of, and then this, I get -1. If I do users dot includes Johnny, I get false. Does anyone know why? It's a little bit trickier to find now that we're no longer working with primitive values, but we're working with objects. Why is it telling me? I'm passing in object with the name of Johnny, and I'm trying to figure out if there's an object like that in my array, but it's telling me no. Anybody know why? Find returns the first. Yes, Alan, you're correct, but you're giving spoilers. You're completely correct. But why doesn't this work exactly? Thank you, Alan. Don't look at the Victoria chat because you just So when you pass something into find, or you pass something into includes, or you pass something to index of, what it looks for is that exact value in memory. Now, if I write a string named Johnny somewhere, and I write another string Johnny somewhere else in my code, those two, as far as my code is concerned, are pointing to the same piece of memory. It's the same value in memory. An object, however, is a different object. So if I define an object, Johnny, here, and I define another object with the name of Johnny, they might have the same properties, but as far as JavaScript is concerned, they are different. They take up different places within the runtime's memory, which means if I set a key, an extra key like age, should I tell my age? 26. 26 on one of those objects, it's not going to affect any other one. Which is why, as far as, even though this looks like it makes sense to us, hey, does users include this object? As far as JavaScript is concerned, you're saying, hey, does an array that has objects A, B, and C contain object D? JavaScript doesn't care that D has the same properties as one of the objects in there. As far as it's concerned, it's a different object altogether. It takes up an entire other place in memory. If you do something to one, it won't do it to the other, which is why it's returning false. It's saying, no, this object doesn't exist in this array. One way we could do this is if, like, let's say, for example, I had new user equals, and then name Emma. And then I did users dot push new user. Now I could do, if I log users, I see my 3 users. And if I do users dot includes Emma, or sorry, new user, I get true. Why does it work this time? So what I did was I created a new user. I'll log it so you guys can see it. I declared the new user with the name Emma. I assigned it to a variable called new user. And then I put a reference to that variable into my array. And so now when I use includes, I'm making reference to that exact same variable. So it's not a new object altogether. I'm saying, hey, does this object that I already defined and referenced in this variable exist in the array? And it'll say yes, because they're both tied to that same variable. Does that make sense? But we don't have that luxury when we're trying to find users. Don't worry, we'll get back to security, but it's important to understand how this find method is working. Find kind of circumvents that because we can't like assign a variable to every single one of our users so that we can reference them later on. That's like, it's not efficient. What we can do instead is we can use a method called find. And find allows us to loop through all of them, but we don't have to define a for loop. Instead, we use this kind of utility method that's going to have that loop run for us, and we pass in a callback. And the callback will be executed, and it's expected to return true or false, or a truthy or a falsy value. But I think it's good practice to make sure it just returns true or false to Boolean, just to make sure that your code is as clear as possible. And then it's going to return, as Alan told us earlier, that it's going to return the value that returns true. The first value in the array for which the callback returns true, it'll return that particular value. So looking at our code, if we go to find user, we call users.find, and then this is the callback that we pass into find. Who can tell me what this code on line 39 is doing? What is this callback doing? It's being executed on every single item in the users array. As a matter of fact, maybe if it'll help if I actually log out. And so I'm just going to get rid of this for now. Find user. And put a breakpoint here. Perfect. Johnny and Johnny. OK, so I have the breakpoint set here. And now I'm executing find user. This is my array. I have a username. I have two users in there. One, I don't know how this happened, but it happened. It has an empty username and an empty password. That must have been a bug. And then this is the one that I defined afterwards. It's going to iterate through this array and run this callback, this function on each of them. And on each of those, it's expected to return true or return false. And on the first one for which it returns true, it'll return that as the user that it's found. Hence the name find user. Can anyone tell me what this callback is doing? So this part that I'm highlighting over here. Yep. I'm going to take this. Maybe it'll help if I put it over here and make it even. Oh. This is the callback. So it's saying on each one of the items in my user array, return true if the user's username is the same as the username from, like that was passed in to the login form. So basically that variable is coming from, let me take a look at our code. Oh, wow. Here. It's going to go through all of them, and if the username of the user is the same as this argument, then return that value, return true. Otherwise, return false. And because the username that we passed in is Johnny, then that second one is going to return true, and that's going to be the user that's found. And then that can be used to compare and try to find passwords. Any questions about that so far? Oh, I see some confused faces. You can tell me if this is a part of it you don't understand. You can kind of think of it like this. I'm going to go back to my screen, or the full screen, actually. Full camera. I would describe it a little bit like this. I said I would find a black marker. Let me try to find a black marker. Just a second.
So I might. What's up, John?
Hey, do you have a black marker by any chance?
Black marker?
Yeah. The ones they are kind of like.
Look like it.
That one.
Oh, that looks like yeah. There is a dark blue marker on my desk.
Okay. Thank you. Hey, I'm wondering if you like a dark blue or black marker. Thank you so much. Okay. So you have an array. Oh, I love this. It has a bunch of things in it, and you want to return one of them. So what you tell your find method is it takes a method or whatever, and it's going to return true, or it's going to return false. So it'll return a Boolean. And then, I don't know write f of x, it's not math, but whatever. It's going to execute that on every single one of these. And each one, it'll say maybe false, it'll say maybe false, or maybe it'll say true. And as soon as it hits true, it'll return that value. As soon as that callback returns true, then your find method will return the value for which that callback returned true. Now, what's the kind of potential pitfall that you might want to avoid with find? Yeah, exactly. If you were to try to find somebody in your user array that has the age of 19 or something like that, then if you have multiple users with that same age, then your find method would only return the first one. If you want to return multiple, what would you want to use instead? And that's the one that I don't know your name, sorry. Yeah. Mel, the one that Mel mentioned a bit earlier. A very similar one. Filter. So filter works the exact same way as find does. Except, instead of returning the first value for which the callback returns true, it returns an array full of all the items for which the callback returned true. So if you know for a fact, like for example, if you're trying to find by username and you're confident that all the usernames are unique, then you're okay using find. However, if you want to find multiple things inside the array that match a particular check or callback, then you'll want to use filter. And of course, if you want to find the index of something, then you can use find index as well, and that's also going to take a callback. Because index of, just like the methods that I showed before, like includes, only works with primitive values, not with objects, because it doesn't take a callback. It just looks for a matching value. Is that clear? OK. Now let's get back into some security stuff and talk about passwords. Because so far, we've talked about how cookies can be used to find somebody after they've closed a tab and open up a new one. But we want to go farther than that. We want to make sure that they can get back like the next day or after they go to someone else's computer. And that happens by storing passwords. And there are lots of ways to store passwords. We're going to talk about some bad ones, and then we're going to work our way up to talking about some good ones. Right now, storing the password in memory in the server is the absolute worst way of doing it. I have it here just for demo purposes, but it is not the way you should ever do it. Because as soon as your server crashes, then everything is gone. Like, you would have to be 100% sure that your server can like constantly run. And even then, it's not a good idea. You want to start using databases. But before we start talking about which kind of hardware or whether or not to store something in the server or the database or what kind of database, let's talk about something a little bit more specific than that. That is, in what form do we want to store our passwords? Does anyone know about What is a safer way of storing passwords as opposed to just having them written in plain text like this? Sorry? You can encrypt them. Yeah, you can encrypt them. Who knows what encryption is? Who doesn't know what encryption is? Put up your hand if you don't know what encryption is. So if I don't know if it, like, back in my day, when I was like elementary school, there was these like things that people could use to like exchange code messages with one another, and you'd each have a key, and that key would say, okay, this letter corresponds to this letter, this word corresponds to this word, and then you can use that to write messages to each other. That if I have the key and Jackie has the key, we can pass notes to one another, and no one else will know what we're talking about. Even if they see the note, they'll be like, I don't know what this is. Here, you read it. And then Jackie can then use his key to decrypt the password because he knows what the code is. That's essentially what encryption is. You're taking something. Am I in full? That's perfect, yeah. I am going to erase all of this. And I'm going to give the most simple example I can think of. Have an encryption key that takes all letters and converts them to a number based on their order in the alphabet. So ABC would become 1, 2, 3. And I can write a message like that and pass it on to someone else. And with passwords, if you encrypt them, then you can use that encryption key to then decrypt them. But that's not the best way. That's not the best way. It's good, but what's the potential? Alan, always coming with the spoilers. Oh, thank you, Alan. Yes, you're right. No one looked at Victoria yet. What is the potential caveat with encrypting passwords in a database, in your server, anywhere? What is the problem with that? Yeah, I mean, a developer could potentially just like, oh, okay, I'm just gonna go see what this person's password is, decrypt it, good to go. Or like, even worse, a malicious person, could like have some kind of code that will go into your server, find that encryption key, and compromise all of the passwords. There's another way that's very close to encryption, kind of, but a little bit different. There's one key difference. Does anyone know what that is? Hashing. Okay. What is the difference? What's your name? Gabby. Gabby, can you tell me what the difference between hashing and encrypting is?
I'm not entirely sure, but I think hashing is like you can't see it on both the server side and like your database, like whatever like key is.
Yeah. Hashing, a hash password will not be able to be decrypted. I mean, sorry, not impossible, but like it'll be very difficult, if not virtually impossible to decrypt. One-way street, exactly. So let's say, for example, I wanted to hash something. A hash, in theory, will take a piece of information, then convert it to something else, but in a way that it cannot be reversed. So if I take a really simple one, one that takes a string, converts every letter to a numerical value based on their order in the alphabet, and then adds all those numbers together. So I take A, B, C. I get 1, 2, 3. And then I should make this much bigger for the people on the other side. So I start with A, B, C. That's a string. And then the step 1 converts this to 1, 2, 3. And then the next step adds those numbers together to get 6. Now with this super basic, never would be used by any company, hashing algorithm, you cannot know from looking at the hash that it started off as 1, 2, 3, ABC, because it could have been just F, because that would also get me 6, which would get me 6. So in theory, something that's hashed cannot be easily reverted back to its original kind of format. And that makes it more secure. Because then what we can do is we can hash passwords that are entered, and then when people sign in, we don't unhash the password because we can't. Instead, the password that someone submits when they hit enter to log in, we hash that and compare it to the hash that we have stored, and if they match, then that means we've entered the correct password, and we can confirm them without ever actually knowing what that password was. Does that make sense? Yeah.
So does that mean that they can enter a different password that's also evaluated to that number, and then they would still go through?
Theoretically, yes. But the hashing algorithms that are out there make it virtually impossible. And there are people who dedicate their entire lives, like mathematicians, who make sure that hashing algorithms can be, it's pretty much impossible to get the same output with the same input. But theoretically, yeah, you could enter a random password and get into someone's email. Yeah. What do you mean by closed or open hashing?
One of them is where if you get the same value, you do point to another point in space, you go down like a pointer, like a late left chain to find the different keys that occupy the same place, and then the other one is it stores a sequential array.
You know more about this stuff than I do, so I'm not sure. I don't know. I don't have an answer for you. Yeah, but I'll look into it. That's really interesting. But yeah, I some of them like more common hashing algorithm that I've seen used out there, like I think SHA, SHA through 2 and 3. No, SSH2 is outdated, but I'm not exactly sure like what methods they use. But I can kind of look into it and see which ones are more common, like open or closed hashing. Yeah, but that's a good question. I'll find an answer for you. Speaking of like ways to kind of break through hashed passwords, instead of randomly guessing and getting the right answer, what is, you kind of have to think a little bit higher level now instead of just code, a way that people could have their hashed passwords compromised? Maybe not on one particular app. I'll give you a clue. You kind of think more widely in the larger scope of someone may get the key to decrypt. Yeah. Exactly, Lord. Lord was answering the question from earlier. Yes. But think about hashed passwords. What's a way that they could be compromised? Yeah. And then what could happen? You're on this. You're like, sorry. It's easily guessable.
Yeah.
Mm-hmm. And then, what could someone do? Yeah. So you have these things called rainbow tables that are available on the internet. And what they are is these kind of databases of commonly used passwords and their hashes. So if someone were to get access to the database of a website along with the information of all of its users, then they could look at those hashes and then compare that to the ones inside the rainbow table. And you wouldn't be able to find everyone's information. But because most people are human and most humans use bad passwords, you'd be able to compromise a reasonable amount of people's accounts because you know you recognize the hashes from looking them up on that rainbow table. Which is why hashing algorithms are constantly updated and new ones come out that are more and more robust, because that allows those tables to become outdated, and the new kind of like hashing algorithms come out with hashes that aren't recognizable by anyone. Any questions before I kind of talk 2 more points about kind of hashing before? Yeah.
I don't yet understand why you want the hash of the password. You have a list of passwords that are already common. What does finding the hash add in your ability to get passwords?
Well, it just adds one extra step. Think about it this way. I'm a hacker, and I have a hash table, rainbow table with the 100 most common passwords along with their hashes from SHA2. And I get access to Chase Bank's user account data. And I find all their hashes, and I know that they're using the same algorithm. Now, why not? How much quicker would it be for me to use that information to basically access their information, as opposed to like going directly into that account data and guessing all the common passwords? So it basically it makes it easy so that if I see a particular hash, I can use that to look up what the password is immediately, as opposed to having to guess. So I mean, technically you could brute force and guess common passwords, but if you have the information already there about all the common passwords and their hashes, then you can just look that up immediately. No, you're not following?
I'm not. I don't know why.
I don't get it either. Why would you, if you have all the common passwords, why not just enter those? What does the hash add?
Because then you know exactly. So here, I'll go for. What's that?
I thought you could like go back into my hash to a
No, you can't go back, but you know. So here, I'll draw this out. Did you already finish the cookie? Okay. What's your name? What's Sarah? Jake? All right, let's go through this. Yeah. So Jake is confused about why would you want to have a rainbow table if instead of just guessing people's passwords. So let's look at an example. I have a rainbow table, which is like a database of all the common passwords and their hashes, and I see password and its hash, which is xy4_9, and I see 1, 2, 3, and its hash is z!1. I then, later on, get access to Chase Bank's information with the users and their password hashes. Remember, passwords are never, when you hash, there's no point in ever storing the password in a database. There's no point. That's the exact reason why I use a hash. So then here, I have user 1, and their hash is 7948. I don't know, @sign. And then I have user 2, and their hash is, I don't know, a smiley. It will never be like that, but. And I have user 3, and their hash is z!1. As a hacker, what can you deduce based on that information?
yes, I now understand where the missing link was. I thought did Chase some of the person data was their account?
No, no.
The account,
No.
Yeah, we don't have Chase Bank.
Oh yeah, Scotiabank. I'm not even from the States. I don't know why I chose Chase Bank. I'm not even from RBC. There we go, RBC. Is anyone still confused by this concept? Okay, cool. Let's look at it in code. So it'll be just a little bit clearer, hopefully. For that, I'm actually going to kill this one. And is this code no bcrypt? Oh, my bad. Sorry. Thank you for reminding me. I'm going to switch back to my screen. I'm going to look at this server.js. And this code uses bcrypt, which is a very common encryption library for Node.js. But it works the exact same way as the app that we just ran through before. The only difference is this one is not going to store the password in plain text. It's going to hash it. And then that hash is going to be compared every time you try to log in. So let me first, is there a check user? Yes. Log in. There we go. So I'm going to node dash dash inspect server.js. I'm going to open a new incognito tab and let's go to localhost 8000. Oh, I should probably delete. User, I'll just use the password user. And let's see what happens when we sources server.js host login. Or no, sorry, sign up. There we go. Perfect. Create an account. Okay, so I just hit the sign up endpoint with a post request, and this is in my request, and the body contains a username and a user. So now I call bcrypt.hash. It's going to hash my password, and that hash is now going to be stored inside the user's array, along with my username. So I'm not storing my password, I'm storing the hash of my password. And now, when I hit the sign in form, so log in, I'm going to put a breakpoint here. And user. I'm making a login request, which contains the username I want to log in with and a password that I want to log in with. And then I'm going to call that find user method, or I guess this time it's like just inline, users.find by user. If there's no user, I just redirect to login, but there is one. And that user has the password hash and the username. Then I call bcrypt compare with the password that was passed in through the login form and the password that is stored in the hash. And there's a callback that will take the result of that comparison. So it's going to be true or false. And that true will tell you whether or not the passwords match, or the hashes of the passwords match or not. And you can do with that information whatever you want. In this case, we're saying if they match, then set the cookie and redirect them to the treasure. Otherwise, then redirect them back to the login. I think we'll leave it at that and take a break and then talk a little bit more about some internet security stuff. But before we go on break, are there any questions? Nope? OK, cool. So we'll give you guys, how long do you usually take? 10 minutes, 15? OK, let's do 10 then. Thank you for all the good questions. I like this. Hey.
Thanks for your.
My pleasure, my pleasure.
Like today we're gonna, I think, add the username password.
Yeah.
Or like tiny.
Yeah.
So that's what. So we should implement like all those stuff. And
Yeah.
for the password, we should just call back and use the hash.
Yeah, yeah, yeah.
So in data we cannot use the password.
No, you should never store the password.
No, we can, but
you hash
don't
it.
want.
Yeah,
We
exactly.
don't want.
Yeah, exactly.
And I think what I learned in university is different
Yeah.
And hashing is that for encryption there is a two-way purpose, like encryption with the decryption. But
Exactly.
for hashing, it's properly designated,
Yeah.
like the. I mean, for hashing there isn't any like return way.
That's right. It's only one way. It's like what we described. Oh, I think I erased it.
And okay, and so we combine the
Yeah.
hash like formula or the pattern with
Yeah.
the password, and then we use it here in the table.
Well, that's something that you should do. That's like I was saying. That's what hackers can do to find someone's password.
Oh, okay.
Yeah, yeah,
But
yeah.
norm, I mean, when
We-
we add an object,
Yeah,
like
we
when-
hash. I had it in there, but you take a password and you hash it and then you store the hash. Yeah. Hey.
You said you did Lighthouse 2 years ago?
Yeah, yeah.
So how are you finding it 2 years after?
Oh, it's good. I'm like, I have a job that I enjoy, which I didn't think was possible.
Yeah.
To put it simply, like I work with some really, really smart people, and I kind of get to, I don't know, I'm learning every single day. So it's been nothing but good things since.
So would you say that you're at like an intermediate level now?
I would say so, yeah. Intermediate. I had studied business in university, and after that, I just spent years just doing random jobs because I didn't know. I thought beforehand, I thought I would wanted to get into marketing, and then I realized I didn't want to get into marketing, so I kind of had like a quarter life crisis, and just did random jobs. Went to Japan, went to Malta, and then eventually I'm like, you know what? Maybe I'll learn to code. It's weird because I had tried to learn to code a couple summers before, but after trying, I had given up. First time because I thought it was too hard, and the second time, I was like, I just finding I don't know. I don't know if you've ever done like Code Academy tutorials,
Yeah,
but you
that's
do
what I
it,
did before here.
but you do it, and then like by the end of it, you're like, okay, I know this, but now what? I still can't build an
Yeah.
app. You know, like you're completing tutorials for the sake of completing tutorials. What happened differently the next time around was when I had a job in Malta where I was doing shit all. I had an idea for an app, and like I was motivated to like build that app. So like I started studying and studying and studying for the sake of like building that and just kind of seeing it come together slowly and slowly. So like even though the app never became anything, I mean actually it became my final project for Lighthouse, but like it never became like my career or anything. Like by the time I was done it, I knew enough that I was convinced that programming isn't just for math geniuses. And by then, like the first thing I did when I came back home was I signed up for Lighthouse. Yeah, that's kind of the biggest thing is like always having something that I want to do with my programming skills as opposed to just learning to code just to learn to code is kind of what helped me cross that threshold from like dabbling into actually making it a part of my life. Yeah.
So what are you doing at your company right now?
I'm a software engineer at Axiom Labs. So I'm just kind of doing mostly front end, but a little bit of back end as well. And we have this kind of project management platform called ZenHub. I don't know if you ever used Jira or something like that. Jira. Have you ever used any kind of like task management software?
Yeah.
So pretty much that, but it's tied to GitHub issues. Yeah. And we have like big like corporate clients. That's kind of why like our software is mostly for enterprise customers that need to like coordinate projects for like big teams and stuff. Yeah, I've been at it for like a little over a year and a half now, and I absolutely love it. But I also like teaching, so that's why I come here every few weeks. Yeah. What about you guys? What made you want to start doing this?
I saw like coding in a movie. one
Yeah.
time. I forget what movie. it was.
Yeah.
And then like it just kind of looked cool. It's like all these millennials are just coders, kind of just living life like on a cool or like luxury stuff. And then I was like, oh, that actually seems like really cool. It's like a hip lifestyle, but they're like getting shit done.
Yeah.
Yeah, and that just kind of made me want to just do some research into it. And then I took some Code Academy courses. And I feel the same way. It's like they get you so far, but
Yeah, by the end of it, you're like, cool,
yeah.
but now what? I got a badge. Now what?
yeah, it's like what's next?
Yeah,
And yeah, this was what's next.
exactly. This is what I like about Lighthouse. They actually get you building stuff. I would recommend if you have the time, like try and build your own thing as well, like even on the side, because then even if it never becomes something, you can come back and bring it to the mentors and like get feedback on that, and that'll just kind of first boost your portfolio, and also like help you learn a lot more than you would just from this stuff. But that's if you find yourself being able to keep up here and still having a bit of extra time. It doesn't happen for everybody. But yeah, I don't know. Like and like grill the mentors with questions. Like that's what they're here for. They're happy to share. Like the more you can learn while you're out here. I mean, you've been told this before, I'm sure, but boot camp is one of those things that you kind of get in what you put in. We had some people who just kind of like went through the motions and kind of barely got through it, and then like they had a harder time finding jobs. Not that that's like. There's also a lot of luck involved. We all know like two people at the same level, one can find a job in 3 weeks, one can find one in 3 months. But I will say that it helps your chances if you like put in effort into learning as much as you can, even beyond what's on the actual stuff. Like not just enough to complete your assignment, but even be like, oh, but why does this work that way? What was that guy's name? That Jake. That kind of questions like that. Like, oh, what is this? What is better for doing this versus this? Like, how do people actually use this? Those questions will kind of help expand your understanding, and it'll just make you that much better of a dev. Yeah. But you guys are a really inquisitive class, so I'm not really worried about you guys. Yeah.
Trying to think which code it was. You just go to
Yeah, of course.
kind of when you were authenticating if the username's been there before or.
Find user or find.
It might be.
Yeah.
Yeah. So are you like looking in the global scope to see if that username exists, or?
Yeah, I'm looking inside this array.
Oh, okay. Fine.
Data is defined here, or sorry, data equals here.
Yeah.
And then I look inside this one. So yeah, this is defined in the global scope, kind of. Well, in the scope of this file.
Yeah.
And when you create a new user, that user gets pushed into this array. And when you log in, I find a user with that username.
And then for your password one.
Yeah. So once I find the user,
Yeah.
I compare the password of that user with the password that was submitted with the login form. And match is going to be a Boolean. It could be true or false.
So
if it's true,
and when you go compare and then you say password right there,
yeah.
is that the input one?
Yes, exactly.
And so where do you define or like?
Where do we get that one from?
Yeah, like where is that?
From the request.
Okay, I didn't see that part.
Yeah.
Okay, rec body. Okay.
Hey, how's it going? Good question, man.
It was a terrible question because I now realize that it doesn't make there's no difference. They would not use either or. They wouldn't because they don't make hash tables. They just save it as a hash.
Oh.
That's for hash tables. Like you always get like, oh, it's already been used. You can't use the same
Yeah.
username or whatever. But yeah, they would. If they run the same hash value, what do? They just save it anyways, or they
Pretty much.
save it much. They just match it to a username, right?
Exactly. Yeah.
Yes, they wouldn't care about.
And so does every company like do they have like a different hash algorithm?
There are some common ones out there. I think maybe some have their like individual ones, but there are some common ones like SHA is a really common one. Let me Google it actually. Like I always Google stuff. Exactly.
Like, I'd want to like find like GitHub for example, like the algorithm that they use.
Yeah.
Because then if you knew that, then you could like test if your password could be different, and then you can still get in. Like just getting that same hash key through a different input.
Hashes are very complicated.
I know,
Yeah,
but like,
you gotta.
ridiculously
People get math degrees to understand hashes. Developers just use them.
They are
Yeah.
impressive. There it is. Look at that.
that's the most common one.
Yeah, SHA is one of the more common ones.
Are we getting going now?
Has it been 10 minutes? Yeah, I think we might as well get started.
Okay.
Is everyone back? Does anyone notice their classmates missing?
Couple.
Okay, we'll wait. Sorry? Okay, we'll wait for him.
How's it working at Accident Zen?
Oh, I absolutely love it. I'm just work with some really smart people. I don't know. And it's like, I was afraid that some startups have a very tough grind culture where they're super early, late at night, like for us, it's like, no, we can just go home whenever we feel like it. Kind of. As long as you're getting your stuff done, there's no pressure to like wear yourself out, kind of.
Awesome.
Yeah.
It's like a good company.
I like it.
I have a friend who works there. Who's one of the founders of CryptoKitties.
Oh, really? Who's your friend?
Jordan, Sean.
Oh, how'd you know Jordan?
Our moms know each other.
Oh, he's such a good guy. This guy's like, he's one of the most laid back people I've ever met. He's just like, he's just kind of, I don't know, man. He's just a gentle giant.
He's so emotionally stable.
He is.
Sometimes it's pretty impressive.
So you knew each other since you were kids then?
No, we met recently because like I was in tech in August, but I wasn't really getting any jobs.
Oh, I see, I see.
Like, oh, well, Jordan works at
This is a nice big company, yeah.
he could probably I was like,
Is he the one who convinced you to join a boot camp?
no, this is just I found that at the tech hiring fair that happened in like Southfield.
Oh, I see, I see. Yeah, Jordan's a great guy. Okay, I think we can probably get started then. I think everybody's here. I really like some of the discussion that we've been having over this password stuff. So I want to take it a little bit farther. Just a little bit farther. Because I have like for this lecture, I have like a little selection of things to talk about. But I figured I'd rather dive a little bit deeper into a couple of them as opposed to just being like, oh, here's a bit of this, here's a bit of that. We'll see how it goes. I really want to kind of talk about this because it relates to what we've been talking about so far, which is, oh, I'm showing my screen. I should be showing myself. 1 second. I want to talk about salt and pepper. Does anyone know what salting and peppering is? So salting and peppering is, in this internet security arms race, 2 of the steps that developers have taken to avoid malicious hackers finding out what people's passwords are based on those rainbow tables or databases of hash passwords that they have. So let's start off with salting. Salting is very simple. What you do, my marker is over here, is in your database, you have ID, you have username, and you have the password. As it is right now, with the most secure way that we know so far, you take a password, which is password 123. You hash it. So you hash it with your hashing algorithm, and you get Z!2. And then you store that in your password, in your database. And then you compare that when someone tries to log in. If someone has a database of common hashes, then they can find this out using the way that we described earlier. With salting, what happens is when you sign up, your password, before it gets hashed, gets a random character added to it, a salt. It can be 7, it can be exclamation mark, it can be at, it can be whatever. So let's say in this case it's the letter Z. So what gets saved to the database is the salt, which is Z. Sorry, we'll put salt here as a column. Z, and the username is, I don't know, user1, doesn't matter. And then password 123 gets the salt with it. So password 123 Z. then gets hashed. Let me erase this. Password123z gets hashed, and then that hash is stored inside the database along with the salt. How does that increase security? Based on what we know so far, how does it make it more secure if we add a random character to every password?
It adds another level of security because then that's another step it has to go backwards to get to the hash.
Yeah. Basically, if someone has a table of all the common passwords, they still wouldn't be able to find this person because this person's password isn't really password123, it's password123z, which can come out with a completely different hash. And you might be wondering, well, then wouldn't the user have to know that their hash is, that their salt is z and adding in? No, that doesn't happen. What happens is when they sign in, it'll find the user, and then before putting the password to be compared into bcrypt, it'll add the salt based on what is already stored in the database. So from the user's perspective, they actually never know. They know that their password is 123, but the server knows that, oh, user 1 has a salt of z, so I'm going to put that salt onto the hash, to the password before it gets hashed, so that we can compare. And now the hashed passwords are a little bit more secure because they're a little bit more hard to guess. Because password123z and password123 will have completely different hashes that make it impossible to know that they're just one letter apart from one another. Yeah?
Is it common to use one letter, or do they use like multiple?
That's a good question. From what I've read, it seems like one letter is more common, but potentially you could add more letters. I would expect that the most robust of hashing algorithms will give you a different enough result if you add one letter versus if you add 3 letters. So like adding more letters isn't going to make it all like more difficult to guess because it's just like there's still one extra step kind of. But that's a good question. Yeah, I don't know.
I feel like there's only so many characters. You could just make a regular table that has all the different.
Exactly. Exactly. Another way of doing it is with a pepper. And a pepper is very similar in the sense that it's something that's added to your password before it goes to be hashed and be stored in your database. The difference is the pepper never gets stored into the database. Because potentially what someone could do, because if you have like all these salts like Z, 1, 2, 3, or whatever that are randomly generated, theoretically you could still go and try to guess. It would take you a hell of a lot longer, but you could try and guess what the passwords are based on that. But if the extra character is never stored at all, then it's even more difficult. Now, the problem with that is that now when someone signs in, you don't know what character to compare it with because the pepper never got stored. And so what happens with a pepper is that it's usually, let's say, PW123. PW123 is a password. The pepper will be a character between A and Z. So let's say in this case it's B. Completely randomly generated. And then that gets hashed and then stored into the database. The pepper itself, the letter B, never gets stored. So no one knows after that first generation what that pepper was. And what happens when you log in is that your server will then hash 26 times, or as many times as it needs to, each of the potential combinations of the password that you passed in and a letter in the alphabet to see if any of them match the hash that is stored in the database. Now, that in practice seems to be not that computationally expensive. So the server can handle running that same operation 26 times or up to 26 times. It could be less than that if it finds a match earlier. And in practice, what ends up happening is that hashing algorithms are so strong, are so powerful that you're very, very unlikely to be able to crack that. So guessing 26 times isn't going to increase your chances of being able to guess someone's password and end up on it randomly. That's how strong. We were looking into earlier what some of the hashing algorithms are. Mathematicians spend their lifetimes figuring out hashing algorithms that make it virtually impossible to guess. So that's another method. I haven't seen it used as often, to be honest, from what I've read so far, but it's also one kind of worth knowing about. But ultimately, I think, in my opinion, well, not in my opinion, in the opinion of many people who build web apps, the best way to store password is what? Anyone take a guess? The absolute most secure way as of right now. It's not foolproof. Nothing is foolproof. But in terms of best practices, what is the most reliable way to store to be able to authenticate users? And you can take a guess by thinking about all the apps and websites that you use right now. Security token. Yes, you got part of it. 2FA, that's the good one. Yeah, 2FA is good. And if you're a smaller company, though, like if you're, sorry, what was your name back there? Fabio, you're right. If you're Google or Facebook or something like that, and you can build a 2FA system, then 100%. But if you are building a final project for Lighthouse Labs, and you don't have the time and effort and resources to build a 2FA system, what's the most reliable thing you could do? She had part of it. What's her name? Sorry, Lindsay. Lizzie had part of it. But what's the bigger thing that is a part of? What did Victoria say? Where's Victoria? Let someone else do it. That's it. The best way to authenticate users is to not authenticate users. And let a big company like Google, Facebook, and GitHub take care of it for you. Authenticating with third parties is something that many, you don't have to take my word for it. Open up half the apps on your phones and you'll see Facebook logins, Google logins, and I don't know, logins with a lot of the big companies that have big teams full of security experts who can make sure that all the passwords that they store are secure. So then you can use tokens to access that data and basically authenticate users without ever having to ask them for a password. And let me take a look at what that kind of looks like, because it's a little bit involved. I'm going to give you an example with the Spotify API documentation. But if you look at documentation for other services like Facebook, the flow is very, very similar. So what first happens is you register your application. So let's imagine that you were doing third-party authentication for your Tiny app. You would register your application on Facebook's developer site. And they would give you a client ID and a client secret. And then when your app runs, when someone wants to sign up with a Tiny app, you are going to direct them to Facebook. And when they get to Facebook, Facebook will ask them, hey, do you want to allow Tiny app to access this, and this? If you've ever had a third-party login on one of the apps that you use on your phone, you've probably seen this app wants access to a list of things. That list of things is called a scope, and it can be things like posting user messages, or posting messages, seeing your email, seeing what your friends are up to, whatever. You define it. When you register your app, you specify exactly what kind of scope you would like, as little or as much as your app needs to function. And then when your user is on the screen where they can click accept or not, they will see that scope and they will say yes, allow, or not. But if they say yes, they will then be redirected back to your Tiny app with a code. And that authorization code is something that your app can now use to request an authentication token. So that happens on trip number 2. Trip number 2 is from your app your Tiny app to Facebook or Spotify servers asking for a token. So I'm saying, imagine me, I'm the app, I'm saying, hey, Lizzie gave me access to her account. Photos, this, and that. She clicked accept. I have this code to prove it. Now I want an authentication token. So I make that request to Facebook. Facebook says, okay, here you go. Here's your token. And now I can use that token to do whatever I want within that scope. Now, normally, if you're just using someone's information for logging in, then all you use a token for is getting the person's Facebook ID or whatever, and then store that in the database, and that's it. However, you can go farther. If you have an app that uses the API of that service, so basically if you have an app that can access your Google Calendar and make appointments, if you have an app that accesses your Facebook and posts on your behalf, if you have an app that's, like we had for Spotify, controls your music and creates playlists for you, then that token can be used to make requests on trip number 3 to Spotify or Facebook servers in order to make changes to that person's account in accordance with the scope that was allowed. Any questions about that? It took me a long time to understand that. Honestly, it took me so long. But then again, I don't know. That's why I ended up writing and making a tutorial about it. This is still a bit tricky, and if I were to show this to you by code, it would take more time than I have time for. One mistake I made when I was a student here and figuring out this stuff is I followed through and did this all in just plain JavaScript, which is fine in terms of like, a learning experience, but like you learn as developers, if you have libraries that can do what you want, especially if it's something complicated, sometimes it's okay to just let the library handle it for you, especially if that library is well used and common and like good practice and used by big companies and secure, especially if you're dealing with people's sensitive information. You probably want to trust the library as opposed to just like, oh, I'm just going to store this token in here, and if whatever happens, then who cares? There is a library called Passport.js, which takes care of all of that for you. So it's good to understand it, but you're not going to have to write that entire code for that flow by hand like I made the mistake of doing. Passport.js handles third-party sign-ins through Facebook. Let me actually look at the docs so you guys can see what I'm talking about. Passport.js is very, very commonly used for third-party logins for, let's see what they have. Facebook, Twitter. Oh, am I showing my screen? Sorry, I need to show my screen for a second. Providers. Yeah, they have Facebook login, they have Twitter, they have Google, and they have some other ones too. I think they have GitHub, Spotify, WeChat, and basically all you do is you put in the code snippets based on their documentation, and basically what it's going to do is once you have those little code snippets in there, it's going to allow you to have someone sign in with those services, and then all you do is store their user ID or whatever it is, and you never have to worry about like figuring out how to authenticate people in the right way. I mean, you will have to kind of understand a little bit how it works under the hood, but the documentation is great, and if not documentation, there are also some great tutorials out there on how to use Passport.js. So going forward with your projects, not just in bootcamp, but also your own personal projects, I know we spent all this time talking about hashing and using bcrypt and things like that. It's really helpful to understand, especially if you get into jobs where you'll be required to take care of that stuff. But ultimately, and this is even how we do it at my job, the most secure way to authenticate your users is to leave the hard work to big companies that have teams dedicated to that. I think we'll leave it at that in terms of security stuff for authenticating users, but I do want to touch just a little bit on what I left out before, which was encryption. So encryption is, let me flip back to the camera because I'm going to be using it. So far, we've talked about storing user information, but there's another important aspect of security that I haven't talked about, which is sending and receiving things securely. That's a whole different concept. And for that, we're going to go back to something that I briefly mentioned earlier, or someone else briefly mentioned, which is encryption. Encryption is important not for storing passwords, but it is important for sending and receiving information. Why is that? Yeah, if I send you an important document about, I don't know, like government conspiracies, and I hash, you can tell in reading the news about the States too much, talking about Chase Bank and conspiracies, and I hash it, it's secure now, but then no one's gonna be able to go back and see what it was. But if I encrypt it, then I can make sure somebody else has that encryption key and can eventually read what it is. So let me draw this out. You have Sally. I keep forgetting there are two people that are always used as like examples for cryptography, but I forgot. Let's call them Bob. So you have Sally and you have Bob. And Sally needs to send a really important email to Bob over the internet. Now, a simple way is like they meet up at some point, they exchange a key, and then now they each have their own key. And then now if they send emails to each other that are secure, then they each know they can each decrypt it. That doesn't happen in real life. What's kind of impractical about that? It's theoretically possible, but what's impractical about it? If Bob's across the world, how are they going to meet up to exchange that key? They can email that key, but now that key is over the internet and it's compromised. What you could do is you could use Google, and you can use Gmail, and you can negotiate with Google an encryption key with them. So now Sally has a key to encrypt her emails as she sends them to Google servers. Google then uses that key to decrypt the email and then encrypt it with Bob's key and then send it over the internet over to Bob. And then Bob, with the key that he and Google know about, can decrypt that message and know what it is. What's the potential downside here? Or what's not necessarily downside, but like threat?
Google can read your message and know what you're talking about and act on that information.
Yeah, not just Google, but anyone who has access to Google's servers. So that's called a man-in-the-middle attack. Someone can get there, and at this point, while it's being decrypted and encrypted again, get access to it and figure out what it is. Is that what you're going to say, or you had something else in mind? In that case, it has to happen at some point. Like when you sign up for Google or something like that, you kind of negotiate a key with them. So really, at least at that point, like, yeah, when you sign up for Google, then you kind of negotiate a key. So that still goes over the internet, but at least that time it's only once. And ideally, you want to be able to kind of protect against that. But there is a way of making sure that even over the internet, things can't be decrypted, which we'll get into. So the key that gets negotiated between this one uses something called asymmetric cryptography, which I will talk about in just a bit. Actually, I'll probably talk about it now, but I just want to make sure that we understand what the weak point is in here. So to kind of get, this will hopefully kind of answer your question as to how can two people make sure, or how can any entities, two people or one person in a service, make sure that they exchange information over the internet in a secure way without any weak points. There's something very commonly used called asymmetric cryptography. And asymmetric cryptography works kind of like this. So Sally has two keys. a public key, and a private key. So K1 and K2. K1 and K2 are different, and they're connected in the sense that any messages that are decrypted by K1 can only be decrypted by K2, and vice versa. Any message that is encrypted by K1 can only be decrypted by K2. So if I take a message, an email, and I encrypt it with this key, it can only be decrypted by that key, and vice versa. Sally is going to pick one of those, so we'll call it SK1, Sally key 1, Sally key 2, one of those and make it her private key, and take one of those and take the other one and make it her public key. Which one she picks does not matter. It does not matter as long as she just picks one of them and makes it public, and the other one makes it private. So the public key is going out to the internet where everybody can see. Sounds dangerous, but it's not, and you'll see why. Bob has the exact same concept. He picked the key BK1 as his private key, and then BK2 as his public key. What is the only way to decrypt a message that was encrypted by BK1? Right. Based on what we know so far, anyone have any guesses as to what strategy these people might use to exchange information securely? This is on the internet. Everyone can see it. Everything above this line is on the internet where everyone can see. Everyone has access to it.
I guess Sally in this case would just say, whatever you send to me, send using SK1, and I can decrypt it. Like, only I can decrypt these messages using my private key.
Yeah. So if Sally wants to send a message to Bob, Sally's going to look at Bob's public key and then use it to encrypt a message and then send it to Bob. So throughout, all while it's going over the internet, anyone can intercept it, but they won't know what to do with it because it can only be decrypted with Bob's private key, which is stored securely and not on the internet. And vice versa. Bob wants to send a message over to Sally, then he can just use Sally's public key to encrypt the message and send it to him. Any questions about that?
So you use the private key of one, send it to the public key of another.
No,
the public key of one, send it to private.
you use the public key of one to encrypt the message. So you take, Bob wants to send hey. He's going to look at SK1, and he's going to use SK1 to encrypt this. And that's going to turn into like XY __7. So XY ___ 7 travels through the internet completely illegible until it gets to Sally's computer, which she then used SK2 to decrypt it and turn it into, hey, you up. No, just hey. Does that make sense? If you ever go on the internet and you see HTTPS, or you see like a little lock icon on there, let me see if I can go to GitHub. I'm pretty sure they have it. I'm sure. I'll just do GitHub. These little lock icons and like HTTPS protocols are for sites that have had their certificates signed using this strategy. So basically, someone like GitHub or a company authenticates who they are with the certificate authorities by exchanging signatures using this way. And if you ever have your own project and you want to get an HTTPS protocol for your website, you're going to end up doing the same thing. So you'll get a more of a practical feel of how this works. I think we'll leave it at that for today. One thing I actually didn't get to touch on too much, but maybe I'll kind of like touch on it just a little bit. I talked about cookies in terms of how to store information about a user. But there are other ways. Let me go back to, let's go back to some session storage for a bit. There's cookies, there's local storage, and there's session storage. We talked about what cookies can be used for. So you log into a page, you close a tab, later on you open the tab again, and you don't have to log in. Local storage, what can that be used for? I think it's something that Lizzie, you mentioned earlier. No, but like way early in the class, I was like, oh, what would you want to store in a cookie? Or was it somebody else? I asked somebody what they would want to store in a cookie, and somebody said, like, form information. Okay, well, form information is something that you would store in local storage instead of a cookie. And local storage is different in the sense that it's a little bit bigger, there's more capacity, it's accessible from any window, it never expires, and it is not sent with every request. Tell me how a university's website might use local storage. A university admissions website might use local storage. Yeah. If you have to type out an essay, and you have to fill out a bunch of different pages with some different forms, then they might store that information into local storage. Those don't go out with any requests because they don't need to. The admissions office doesn't care, like they don't need to receive anything from you until you're done. However, for your convenience, they could write some code that stores your progress on the website, sorry, on your client. Let me draw this out. Anything from, can you create multiple tokens so that you can transfer information from one application to another? Terrence, I'm going to get back to your question in just a bit. So local storage. I have a university like UBC that has a website, and you're filling out your application. So you make a request saying, hey, UBC, I want to see the application form for your, I don't know, nursing program or something like that. And it sends that HTML along with some JavaScript that's going to store on your local storage how far you've gotten with each form. There is no reason for any of that information to go back to UBC because they don't need it. They only want to know when you're finished. So instead, when you make requests, you'll get, if you like close the tab and you go back again with the same browser, you'll go get the HTML for the admissions form, and then that JavaScript is going to find inside your local storage the progress of the form that you've already filled out and fill that in for you. That's the kind of thing that local storage can be used for. It has nothing to do with authentication or figuring out who you are. It's just convenience. So things like partially filled forms, things like settings, things like language settings. Those are things that are going to be useful for storing in local storage for the convenience of the user. It's not necessarily sensitive in terms of security. If anything is secure, then you might want to stick to having cookies available or just storing things on the server side. And then you have session storage, which is similar to local storage, but it's a little bit trickier. This time what we're doing is, instead of storing the progress here, it's a little bit involved. We're storing a cookie. Or actually, no, sorry, this is server-side sessions. Session storage is similar to local storage, but the difference is those ones close whenever the tab closes. There's something else called server-side sessions, which you're probably not going to use, but I'm just going to mention it just in case. A server-side session is where you store something on a cookie, just like, I don't know, an identifier like 71 or something like that. And then on the server side, in memory, you store information that is temporary about the user. So let's say, for example, for our UBC example, that would be how far they've gone in terms of filling out the form, or how many options they filled out. We store that on the server, and keep it with a cookie. And now, when they log in again, or sorry, when they open a different tab, we find that cookie, and we reference that with the server side session, and we're able to kind of send back information about how much they filled in and fill that on the client side. It does the same thing as the example I described before, which is the local storage. The only difference is the data that you would store on local storage, you now store on the server, which gives you a bit more control. But if it's really, really simple data, I don't see a point of doing this. I've never done this in my entire life, but it's important to know. It is possible to store session data in memory on the server. But more often than not, like 90% of the time that I've seen, like temporary data that's there for the user's convenience is going to be in local storage or in session storage. And the difference between those two, the main difference is that local storage has more space, and session storage, not only does it have less space, but it also is gone as soon as you close the tab. To close off, I'm going to answer Terrence's question. Can you create multiple tokens so that you can transfer information from one application to another? Google Play Music. If I like a song in my app, it sends a like using the API to both companies for the same song. Potentially, yes. I mean, what you could do, you would have to have each of the different companies authenticate you individually, though. So let's say if you want to like a song for Google Play Music and Spotify, then you have to negotiate and go through the process I described earlier. Where was this one? The auth flow individually with each of the services. So you have to accept permissions for Apple Pay, for Apple Music. You have to accept permissions for Spotify, and you have to accept permissions for Google Play Music, and then get 3 different tokens, one for each one, which you can then use to like send likes to each one. So to answer your question, Terrence, yes, but you can't do it at once. You have to get separate tokens for each one. Let me know if that answers your question. In the meantime, I'll see if anyone else has a question here. No? None? We're good? Cool. I'm around for the next hour if you have any more questions. Thank you guys, and yeah, good luck with your projects. I wasn't expecting that, but okay. Yeah. What's that?
Cohort. We like applauding.
Does that happen a lot with your cohort?
It's our we like to applaud our lecturers.
Oh, that's a good cohort. Sorry? Yeah, of course. Ask me anything.
So, for the local storage, I got that when we request to the intended website, we get that page or that response.